Hi, in this video we will see the execution and simulation of the 3D model of the rotary inverted pendulum setup. So what do you see here in between? This is a mathematical model created by 3D mechanics editor of 20sim software. So if you double click on this, it will open the 3D mechanics editor of 20sim, in which the users can describe the mathematical representation or 3D model of your system. So here you can see that the different bodies are interconnected to each other to create the 3D model. So you can see that this is the horizontal arm, then this is the vertical arm, and connected with the sphere at the top. You can see here that is a sphere. Okay, the arrow is representing the force which can be externally applied on it to add a disturbance to it. The rotational joint over here, the Z1, is used to actuate through a motor. The X, in the X direction, this vertical arm, okay, that would be used for non-actuated joint. So 20sim can generate the 20sim model of it and the scenery files which I have already created and generated. So in this we have one input which is being applied to its motor joint, and we are measuring two outputs from here. One is the horizontal arm position and the vertical arm position. So there is a friction model also for the vertical arm, and that is the disturbance we are adding at the tip of it as in force actuator. So let's simulate this. So I just bring back some values from initial. So here you will find that the initial value of X and Z is 0. So if you simulate this, so this is how the response you get. So the initial pendulum position was at upright, but if you give a disturbance to it, it will start rotating and will keep on rotating and will settle down to a value finally. So this is what the plots we can see. So this plot would be vertical arm angle. So the blue line is the vertical arm angle. So I want to start the vertical arm from the downside position. So click on parameters, pendulum V3. So I tell him that initial X position is pi, that is 180 degree, shifted 3.14. So here you can see that in the simulation model. So it starts from the bottom side. So I just change the camera. Here we can see more clearly. So I just reset the real-time simulation. So it's the bottom side, the disturbance is applied to it and it starts swinging. The swing interval and the amplitude and the oscillations will be totally dependent on the friction model, the mass of the pendulum sphere, and also the length of the pendulum arm, and also the friction model. You can see that the horizontal arm is not moving. That is because in the friction model, which is this one, in this friction model, I have set the value of the friction as very high. It's 1000. So if I make something low values like 100 micro, or maybe 100 micro Newton meter per radians, and you can see that not only this arm rotates, but the horizontal one is also rotating, and that is rotating more. So I had to increase the friction of this joint so much that it do not move. So for that I go to parameters, go to friction block, and I make it 1000. So the friction is so high that it's kind of locked up. Although you see some oscillations, but these values are in micron, very micro angles. So it might be vibrating a little bit. So that's what you can see here. You can see the effects of various change in parameters. For example, the sphere mass, I change it to 35 grams, and thereby you can see a small change in the oscillation cycle. So Thereby you can see that. So I change it back to 31, which is our desired value, and that's the vertical arm mass. I decrease this by some value, and thereby you can see a difference in simulation results. So oscillations are more and set. The user has to work on the parameters and set the right parameters for their 3D model. Thank you very much.